Hello, I'm Dr. Gorgon, and today we're going to talk about selection sort. So let's say that you want to sort a list. We'll use these cards as our list. Trouble is, even though we as humans can see that if we're sorting alphabetically, the 2 goes first, the computer can't. This is the view of the list that the computer sees. It can tell where the list is. It can't see any of the individual components without deliberate access. The computer thinks that it might be possible that the first card might be the minimum, so it's going to look. And as far as the computer knows, this card is the only one that it's seen so far, so it probably is the minimum for this whole list. But it's not sure. It needs to look at the next card too. Well, the computer is willing to admit that it is wrong. So, since the second card in the list is smaller than the first card in the list, it'll let go of that first card being the minimum. But what if the second card isn't the minimum either? It has to keep looking. Since 5 is still less than 8, it moves on to the next card. But since 4 is less than 5, it'll let go of that second card, potentially being the minimum. And now there's just one card left to check. Are you ready? The computer discovers that the 2 is less than the 4, and therefore the 2 is the minimum in this list. So it doesn't need to see the 4 anymore. It's got the 2. But now what does it do with it? Well, since this is selection sort, we've found the minimum, and now we need to put it at the beginning of the list where it belongs. We remove it from the list, and then we insert it at the beginning. So now the process repeats. But we don't need to search for the minimum in that very first card. It's already in its proper place in the list. The snake points to the place where the next minimum card should go. And the trophy shows the card that we humans know should be the next minimum. But the computer doesn't know that. The computer starts looking for that first minimum card with the card that the snake's pointing at. And as far as it knows, that is the minimum that it's seen so far. But it's all too willing to give up that idea when it finds the 5, which is definitely less than 6. And then it moves on to the next card. Since 8 is not less than 5, it'll just go on to the last card. And when the computer compares the 4 to the 5, it finds that the 4 happens to be less than the 5 after all, and it's found its new minimum. So now that it's found its new minimum, it has to insert it back at the place where the snakey is. So the 4 was removed from the list, and then inserted back at the point where the snakey was. And now the snakey increases. Because remember, the snake points to the next place where the new minimum should be inserted. And the trophy points to the card that we humans know should be the next minimum. So because the computer has no need to look through the first 2 cards, which are already in their proper place, it starts with the card that the snake is pointing to, which is still a 6. And as far as the computer is concerned, that's still the minimum that it has seen so far. It found a 5, which is less than the 6. So it doesn't need to keep track of the 6 anymore. But it's still not sure that 5 is actually the minimum. What if there's a card that's less, all the way at the end of the list? It has to go check. Well, nope, it turns out that 8 is still definitely not less than 5. So it ignores the 8. It turns out 5 is definitely the card that we're going to want to insert where the snake is. Yay, we inserted the 3rd card where it is supposed to go. And now we're almost done. The snake moves over, and Medusa, well, the computer starts looking at the card that the snake's pointing at, which is indeed a 6. The 6 is less than the 8, so the 6 is our minimum. But because that minimum is at the same point where the snake is, it doesn't need to be inserted and removed. it can stay there. Similarly, the last card is by default the minimum of those that are left and does not need to be inserted from its place in the list. This list is already sorted.